Hello, lads. So, suppose today we're going to have a look at some tougher examples of questions. So the first one we're going to have a look at is it's from a paper. It's a nice little paper I found online. Okay, so just bear with me while I draw the diagram, and we're going to explore this diagram. So there's a bit of fun involved in this diagram. I love these diagrams. There's always a bit of fun. You can always explore different areas of it. So we have a little triangle, okay, and we've got a line here, and we have some information. Okay, this is the point A, and it's 0, 6. This is the point C, and it's 4, 2. This is the point B, and we know nothing about it. And this is the point G, and we know it's 2 over 3 and 4 over 3. Okay, so we have a bit of information about it. And we're told a couple of little things just to kind of help us off. We're told that it's a triangle. They give us those coordinates, and they tell us something. They say that G is the centroid. Okay. Now, this is the important bit. Okay. G is the centroid of this triangle. So everyone's with me so far on that one. No one's lost me so far. The question is that if we extend this line, okay, it intersects at the point P, okay? And this is the important bit. The length of AG as a ratio of the length of GP is 2:1. And the first thing we're asked to do is find P. Okay, then find B. And things are going right. Prove C is the orthocenter. Interesting. Okay, so we've got our work cut out for us on this one, lads. There's a couple of ways you could go around it. So I'm going to do what, I'm going to let you rip on this one. I'm going to do the 3, 2, 1 pause, and you're going to give it your best almighty shout. And then I'm going to dive right in and we're going to give it a go. Okay? Give it our best shot. I mean, I suppose we have to. Okay? If we don't, you're kind of, you're kind of stuck at some type of ratio type of situation. But listen, give it your best shot. Okay? Personally, looking at it, that's actually the easiest one to figure out. Would you believe the second part? So you can actually just, dive right in if you really want to, but, totally up to you. That's not too hard. There's probably a couple of ways around getting that one. Okay. And then C, of course, you need to know what an orthocenter is. And if you haven't a clue what an orthocenter is, you're going to be in a bit of trouble. Okay. And if you're doing an orthocenter is, you're going to be grand. Okay. So anyway, I'm going to do a 3, 2, 1, and you're going to give it your best shot. 3, 2, 1, go. Okay, and we're back. So let's have a little exploration of this. What do we know for sure? Okay, we know that the length of AG from A to G is twice the length from G to P. Okay, so just think about that. Wouldn't that make sense that from there to there is half from there to there? Okay, you getting me? I think you're with me on this one. Okay, but listen, if you're not, don't worry about it. Okay, if not, we'll figure it out. That's one way of doing it. Okay. What's the other possible ways you could do it? Okay. Well, that's a ratio. Okay. If you know the ratio of the lengths, then if you got the length of that one, this has to be half that length. So you could actually work out this is x1, y1 and try and figure that out. It's another way of doing it. What about the third way? Is there another way you could possibly do it? Trying to think and trying to spitball here. Let me think. So how are we going to fix this problem? All right, I suppose this is the first thing we need to do is just kind of see where we are in terms of what we have available. I know for sure that the centroid uses those 3 points. So in order to find B, you could make that answer equal to those 3 and solve for the x and y one, but that's B. What I really need to look at is P. So let's have a think about this, I suppose, logically. I suppose it's the best way to kind of look at it. So I'm just going to flip a page here so we can look at A in a bit more detail. Okay, so maybe instead of flipping a page, it would make more sense to just fold the page, so at least you can see the diagram at the same time as me kind of having a think about it. Okay, so hope that looks a bit better, and what we'll do is we'll do it over here and see where it ends up. So what do we know about A? Well, we know that we could work out some type of translation on this. Why? Because we know that 0 goes to 2/3 and then 2/3 on to whatever it is, and the same 6 goes down, so it's decreasing. So let's try and work out something like that. Okay, so 0, this is part A. Okay, so 0 and 6. That's what we're starting at, and that goes to 2/3 and 4/3. So what's happened between that point? Okay, you've added a third and you've taken away something. So you've added 2/3 and you've taken away, okay, let's do this on a calculator. 6 times 3 is 18/3, and we're left with 4/3. So we've lost 14/3. Yeah, we've lost 14/3. Okay, so that would mean by logic that if it was the same distance again, you do the same thing, but it's not the same distance again because this is a ratio of 2 is to 1. So it's half the distance again. So really what I'm going to add on here is half of 2/3. Okay, so it's going to be that plus half of 2/3, and on this one it's going to be same thing. I'm going to add on half of minus 14/3. So God, okay, so it's 2/3 plus a half of 2/3. That's 2/3 plus 2/6. 2/3 plus 2/6 is 3/3. It's 1. It's 1. Okay, and then 4/3 plus a half, so that's 4/3 minus 14/6. So that's 8/6 minus 14/6 is minus 3/3, which is minus 1. So that's my point. Okay, so I got it using translations, but the translation wasn't a 1-to-1 translation, it was a 2-to-1. So just be aware of that. You had to half it basically. So that's an interesting one. Okay, so part B then. Part B is find B. Okay, now to find B, we could go the centroid route, or what do we know about the finding the centroid? If we were to draw the centroid, we know it's bisect this line, and the point of bisection, the midpoint to A, would give you one of the centroid lines. So that P has to be the midpoint of BC. So P, the point P, is the mid point of BC. Okay, so if it's the midpoint, you know, a couple of different ways you could find it. You could, you know, do it as the midpoint formula, find the x and y, or you could just do the translation. You know, 4/2 goes to 1/-1 goes to, you know, you're taking away. We'll do that way. I think we'll just do translation again. Okay, 4/2. Sorry, 4 and 2 goes to 1 and -1 goes to, well, you took away 3 and you took away 3, aren't you? You're taking away 3 from both of them. Okay, so take away 3 from that, you're going to be left with -2. And take away 3 from that, you're going to be left with -4. So translation again, except in this case, you're taking away 3 from there to there, there to there. And because it's the same distance, and we don't have a 2-to-1 ratio, it's the same distance, it's the midpoint, you're taking away 3 again. Okay, so that's where we're getting that point from. So I hope that makes sense to you. Okay, so it's actually 2 translations, which is quite interesting. Part C then. Okay, let's flip back over and see what part C was. Prove that C is the orthocenter. Okay, so what do we know about the orthocenter? We know that the orthocenter is the perpendicular point from an apex to the opposite side. So this is interesting. Okay, if they're saying that's the orthocenter, then they're saying that this is a perpendicular line and this is a perpendicular line. But sure, if they're perpendicular lines, let's just show them by getting the 2 slopes and showing that when you multiply one slope by the other, you get -1. So let's just do that here. God, that's not going to take too long. Okay, let's see the slope of AC and then get the slope of BC. Get the slope of BC, and when you multiply them together, you should get -1. -1. So let's see that. The slope of AC, what I got here, y2 minus y1 over x2 minus x1. That's -1, I think. Could be wrong there, but I think it is -1. Okay. Slope of AC is -1. And let's get the slope of BC. Well, let's actually, I'm just going to put in that point there. The slope of BC is whatever minus, was it -4 and -2? -4, -2. -2, -4. And it's going to be y2 minus y1. That's 6 over x2 minus x1, 6, which is 1. And is -1 times 1 -1? Hell yeah, it is. So AC is perpendicular to BC. Therefore, there are orthocenters. Is that C? Okay. So because the slopes are perpendicular, no. Now, is there another way of figuring it out? You could try and get altitudes from opposite sides. You get the slopes of both of them and show, oh, listen, that's just too crazy. You're better off just getting the slopes. I was going to say you get the equation of both lines and show that the equation of both lines have perpendicular slopes, but that's just crazy. Okay, so there's a little sample of a leaving cert question. Okay, now you might be asking and screaming to yourself, well, sir, how much is that leaving cert question worth? That whole thing I just did was worth 25 marks. 10 marks for part A, 5 marks for part B, 10 marks for part C. Yes, I hear you scream and shout, you are not serious, but I am. That's what that was worth. Why is that? Why would I consider that a tough question? Because the following. We have taught this through the lens of physically drawing it using compasses. Okay? But what they've done is they've turned that on its head and asked you to do the same thing, but using the actual coordinate geometry end of it, okay, as opposed to the synthetic-y bit, okay? So they've totally turned it on its head, and for a lot of students that could cause a problem, but not for you, because I know you won't. Okay, we leave it at that. Take care. See you in the next video.